Hello everyone, welcome to my presentation. I'm Neeraj Kumar from CSC section B. Today we are going to discuss polymers and advanced technology used to make different kinds of materials used using polymers. Optical polymers were engineered in many laboratories worldwide and some are available commercially. Classes of polymer for use in integrated optics include actualized polymers and olefins. Example cyclobutane, cycloheptane and so on. Many companies use such polymers. They include Allied Signal, Ameco, Dow Chemical, DuPont, General Electric, JDS, Uniphase Photonics, and etc. Such companies and their properties and polymers were included are tabulated in Table 1. Table 1 shows the manufacturer, polymer type, patterning techniques, optical laws, and other properties of the polymers. We can see many companies like Allied Signal, Omega, Dow Chemical, DuPont, etc. And Allied Signal mainly manufactures acrylate and halogenated acrylate. Hal- Acrylate is mainly manufactured by photoexposure or wet RIE and laser ablation. Same as halogenated acrylate is also manufactured in the same manner. Ameco mainly manufactures fluorinated polyamide with the same with photoexposure and wet tech. Make a note of this table. Now let's discuss different properties and different kinds of behavior of polymers. Optical loss is one of the important properties of polymers. The results of spectrometry studies performed in a set of acrylides are shown in figure 1. Notable features in these figures are the region of transparency around the datacom or computing wavelengths of 840 nanometer, the CH vibrational overtones found in CH bond containing polymers which are most pronounced beyond 1 micrometer, and windows of transparency near 1.3 and 1.55 micrometer. The wavelength of interest for telecom. Optical absorption in polymeric materials is determined both by the energies of molecular or polymeric electronic excited states and by the locations of fundamental and overtone vibrational excitation of covalently bonded nuclei such as carbon and hydrogen. The location of the vibrational sites is determined largely by the spring constant of the bond and reduced mass of the two nuclei. Thermal stability is also the one of important properties of polymers. Thermal stability is the stability obtained when temperature is increased or decreased for a polymer. Key characteristic for practical application is thermal stability of optical properties. Since organic materials may be subjected to yellowing upon thermal aging, typically such aging results from the formation of partially conjugated molecules or group characterized by broad ultraviolet absorption bands which scale of intensity through the visible. This yellowing is strongly influenced by the chemical structure of the organic polymer. Although the allied signal polymer systems described here are acrylic, the chemical characteristics of various backbone segments can vary substantially. Um, For example, simple aliphatic to aromatic and ether to ester to urethane. The choice of these linkages and monomers or oligomers ultimately determines to a significant degree the characteristics of the resulting, including surface energy, hardness and toughness modulus, water uptake, and stability to word aging. However, a much more important thing is that three tension of high optical transmission upon thermal aging, thermal coloration, is a common problem with organic polymer when exposed to elevated temperatures and must be minimized for applications as optical materials. The next property we are going to discuss is humidity resistance. Non-halogenated polymers were subjected to humidity cycling tests. Sample was prepared on a flat glass substrate. Multimode 90 degrees in plane bends were produced. The guides were 100 micrometer in cross section and 10.9 centimeter long. The tested devices were calculated with 100 micrometer core fiber, but were not packaged or protected in any manner. A thin cladding was printed around the core layer to give a short path to the diffusion of water. The sample was cycled between rigorously dry and humid 85 degrees Celsius to 85% RH conditions for over 600 hours. Transmission measurements were performed 150 nm. The results are shown in figure 6 and they reveal that no increase in loss was observable. The present observations also, evidence of mechanical failure of devices due to water link card elimination or loss of integrity interface with the glass fiber. The fact that humidity was very little effect on these polymers was expected when fully cured. These materials have a large high level of cross-linking resulting in a tightly bound network. The graph shows humidity induced relative humidity and time in hours. On y-axis, humidity induced and relative humidity were placed. On an x-axis, time is placed in hours. Final and important property of polymers is refractive index dispersion. Many optical systems rely on having no wavelength dependent optical effects other than those geometrical design into the system. Therefore, material dispersion is generally to be avoided. The refractive indices of several polymers and standard materials like silicon dioxide are measured at various wavelengths in order to obtain value of dn by d lambda. Lambda is the wavelength of the light. Results at key communication wavelengths are shown in Table 2 for non-halogenated core and cladding polymers and the standard SiO2. Now we have a look on Table 2. While the values for the polymers are comparable to those for silicon dioxide, they are much lower than those for semiconductors or doped glasses. Doped glasses are Doped glass is a trace of impurity element that is introduced into a chemical material to alter its original electrical or optical properties. When doped into crystalline substances, the dopant's atom get incorporated into its crystal lattice. Note that table 2 includes dispersion in the refractive index due to both the primary electronic absorption. Pause చేసిన రికార్డ్ చేయకుండా మాట్లాడితే దవలాగా ఇక గుంజుక రావాలరా 9 minutes అయ్యింది అట్లీస్ట్ 12:13 ఇంకో 2 స్లైడ్లు ఉన్నాయి
ఎక్స్ప్లెనేషన్ మినిమం 2 to 3 minutes ఉండాలి. ట్యాంక్ ఎప్పుడు కూడా 1 minute పెట్టాలి
అంతే ట్యాంక్ ఎట్లా చెప్పాలా సో దిస్
Thank
ఈజ్
you. I
ఎండ్
hope
ఆఫ్ ఇట్లా దిస్ ఈజ్ ఎండ్ ఆఫ్ అవర్ presentation. I hope you enjoyed and I hope you understand
my presentation
అది ఉండాలి. I hope end of
you
my
understood at
presentation
least a bit about my
and about
topic.
my presentation and you I think you got gained knowledge regarding polymers and advanced technology used in polymers. పెట్టి థ్యాంక్ యూ హ్యావ్ ఎ నైస్ డే అంతే
Yeah, 1 minute వస్తారా?
వస్తుంది
40 seconds వస్తుంది అది.
45 దాకా వచ్చింది అనుకో అట్లీస్ట్ 13 దాకా చూసుకొని వచ్చింది
నాకు ఇంకా 1 minute వచ్చింది ఇందాక.
Table 2 shows the values of dn by d lambda for two allied signal optical polymers and silicon dioxide. First column is of sample like core, cladding and silicon dioxide and next three columns are about dn by d lambda or around 10 power minus 6 per nanometer at 840 nanometer, at 1300 nanometer and at 1550 nanometer. The sample core has a dn by d lambda value of minus 21.1 into 10 power minus 6 per nanometer at 840 nanometer and has value of minus 4.9 at 1300 nanometer and 1550 nanometer has minus 2.8. Cladding has a value of minus 16 at 840 nanometer and minus 3.8 at 1300 nanometer and minus 2.2 at 1550 nanometer. SiO2 has the value of minus 12.6 at 840 nanometer and minus 3.1 at 1300 nanometer and minus 1.8 at 1550 nanometer. These are the different values of dn by d lambda around different values of wavelength like 840, 1300 and 1550 nanometer. This slide is about different types of polymers. First is optical fiber. It is important part in our day-to-day life used for internet, ethernet and etc. It is made up of different kinds of layers. First layer is of black polyurethane outer jacket and second layer is strength membranes and third layer is buffer jacket and fourth layer is of silicon coating and fifth layer is cladding and last layer is core. It is made up of silica. N number of monomers undergoes polymerization, that means undergoes self-inclination to form a polymer. It is one of the important polymer in chemicals and it is also one of the important polymer in chemicals. These are optical plastic used in our day-to-day life. Polymers play an important role in our day-to-day life. Okay friends, this is end of my presentation. I hope you enjoyed and you gained a bit of knowledge regarding polymers and advanced technologies used to make different kinds of materials used polymers. Thank you. Have a nice day.